Hello everyone. My name is Nguyen from Q Traffic Technology. Our team consists of 3 members: Nguyen, Kamada and Shikanai. Today I would like to propose traffic control solutions to solve the global traffic congestion problem. Do you know that our world is losing more than $1,000 billion every year due to traffic congestion? In fact, this number is statistics from INRIX, the world's largest traffic statistics company. It was collected from more than 100 cities around the world with high traffic volume and density, and when looking at the economic damage caused by traffic congestion in 7 representative countries, a loss was found. For example, annual losses are $371 billion in the United States, $308 billion in China, $105 billion in Japan, $172 billion in Asia, and $100 billion in the United Kingdom and Germany. In other words, traffic congestion not only wastes time, but also causes various impacts such as lost fuel costs and CO2 emissions due to power outages. In the case of Japan, about $105 billion are lost every year due to traffic congestion, but experts say that if traffic congestion can be controlled, it can be reduced by about 40%, or $40 to $50 billion per year. Now let's explain how traffic signals are currently controlled. The left side is the traffic signal control mechanism. The right side is a mechanism to perform real-time signal control by IoT in developed countries in recent years. In this way, although the traffic signal control is mainly controlled by the conventional cycle control method as shown on the left, traffic congestion has been alleviated to some extent by real-time signal control as shown on the right in recent years. However, when expanded to actual map information and scale, the amount of calculation becomes enormous, especially in populated areas, so real-time control is often difficult with current systems. Therefore, we propose an optimized platform for large-scale traffic light control using quantum computing. A simple intersection model and control method using quantum annealing have been proposed. For example, on the left is the intersection control model proposed in a paper published by Toyota Central R&D Labs. We actually simulated this paper as shown in this figure and analyzed the results. However, since these studies are only assumed to be simplifications, there are many obstacles to actually recommending them, and we think difficult. Therefore, we want to realize a new control calculation method and its system as the target of the actual control system as shown in the right figure. Next, here's an outline of the intersection control system we're considered. First, the hypothetical system builds map information and real-time traffic information on a cloud server. It is then used for information processing and cloud optimization problems. The result can be fed into a quantum annealing such as a D-wave for optimal signal control. The features of this system are summarized in 3 points. The first one is to process map information. The second one is to set up a cost function to process the maps. The third one is a redundant configuration for year-round stable control. This is a picture of the product. First, it provides public organizations with real-time signal control information. In addition, we will provide accurate traffic information such as traffic jams for general participants. In addition, real-time signal control information will be accurately provided to other service providers. Assume that there are 3 types of users of this system. 1. Public institutions. 2. Road users in general. 3. Companies that provide services to this industry. Traffic users in general will provide free traffic jam information through the app. Here, the actual map was processed. The results were continuously driven using quantum annealing, simulation and existing controls, and the results of dwell times were statistically analyzed. The verification results are explained below. First, continuous control is exercised using parts of Sapporo City and Sendai City. By using quantum annealing from the graph, we think the downtime can be reduced by about 57% to 73%. Next, continuous control was exercised using the areas of Tokyo and Kyoto. By using quantum annealing from the graph, I think the downtime can be calculated by about 65% to 70%. Next, continuous control is performed using parts of each of Osaka and Fukuoka. By using quantum annealing from the graph, I think that the downtime can be calculated by about 72% to 76%. Next, I will explain the business model. The Q traffic technology we propose will first provide a traffic control platform and will be provided free of charge to end-user traffic users. On top of that, the more users there are, the higher the traffic control system will be, and at the technological maturity stage, we will approach the companies of paid users and start paid services. As for the value we provide, we would like to propose zero congestion time, zero CO2 emissions, zero traffic accidents, and other services. As for the business model strategy, Target 1 will be free users. At the same time, in Target 2, joint research verification will be conducted to improve the degree of technological maturity. Target 3 and Target 4 are the traffic management centrals and the companies, respectively. Next is the research and development plan. Currently, in the step 1 can handle simple real map processing, but we will make it possible to handle more complicated map in the future. We are planning to make a collaboration with a city of Vietnam, that is Nguyen's hometown. We also hope to make a collaboration with a city in Japan. The system technology will be improved and we hope to expand to USA in the step 5 before starting the service in over the world. Next, regarding our target market size, the market size of the target 7 areas is about $10.55 billion USD per year. In the future, we are currently mainly engaged in existing research and development, market research, and patent application verification. It will be such activities in the next 4 years. This is the structure of the business. Our team currently has 3 members and Professor Ozeki as advisors. Here is our vision. We wish to solve the global traffic congestion problems. To make a smart transportation system, no accidents, no useless stops. So we welcome all of you to join us to make it happen. Thank you for your attention.